Section 9.2, Part 6. Lesson objective. State the point estimate and the margin of error given a confidence interval. Lesson objective. Are you a couch potato? A recent General Social Survey, GSS for short, asked respondents, on an average day, how many hours do you personally watch television? Below is the printout for the GSS variable TV. So we can see that our sample size was 899 people. This is our sample mean. This is our standard deviation, S. This is the standard error. And here we have our 95% confidence interval. Number 1, identify the value of the point estimate of the population mu. Number 2, what's the value of the margin of error? Number 3, express the confidence interval in the format point estimate plus or minus margin of error. Number 4, write a statement that interprets this confidence interval. So we are given that we are 95% confident that mu is between 2.69 and 3.04. So if we look at this visually, x bar, or point estimate, is exactly in between these two values. So if we think about it, if we take our upper limit, which is x bar plus e, and then we add our lower limit, which is x bar minus e, and if we were to add these two together, we would have x bar plus x bar, and then we'd have a positive e and a negative e. They would cancel, so we're left with 2x bar. So if we take 2x bar divided by 2, we get x bar. Now if we wanted to find the margin of error, e, we would take the upper limit and this time subtract the lower limit and divide that by 2. Now why does this formula work? If we were to take x bar plus e and subtract x bar minus e, the x bars would cancel and we would have e minus a negative e, which would give us e plus e, or 2e, and 2e divided by 2 is e. So let's go back to the question. Number 1, what is the point estimate for the population mu? That's x bar, which gives us 2.865. And of course this agrees with the printout Minitab. You may be thinking, why did we have to go through this if we already had the answer right here? Well, sometimes we're just given only the confidence interval, and this is how we can find the point estimate. Number 2, what's the value of the margin of error? So if we use our formula, take the upper limit minus the lower limit, we get 0.175. And you may ask yourself, how do we know how many decimal places to take it? Well, if it doesn't specify, usually we take it one more decimal place than what's given. So this is 2 decimal places for the confidence interval, so we want to go 3. Number 3, express this as point estimate plus or minus margin of error. So x bar is 2.865, margin of error is 0.175. So we are left with 2.865 plus or minus 0.175. Number 4, let's interpret this confidence interval. We would say we are 95% confident that the true population mean for watching TV on an average day is between 2.69 hours and 3.04 hours. Next example. When 13 different second-year medical students at Bellevue Hospital measured the blood pressure of the same person at about the same time, one after the other, they obtained the following results. Measured in measured in millimeters of mercury. So we are given 13 values. We're going to assume that this comes from a population that is normal. A, what's the best point estimate for the population mean? B, construct a 90% confidence interval for the population mean. Then we need to interpret it. And C, ideally, what should the confidence interval be in this situation? Here's the Minitab printout. This is X bar, this is S, this is the standard error, and we have our confidence interval. So the best point estimate is X bar. We have 134.2. Our confidence interval is 129.7 to 138.8. And to interpret this, we'd say we're 90% confident that the true population mean for this person's blood pressure is between 129.7 millimeters of mercury and 138.9 millimeters of mercury. You can see ideally all the measurements would be the same, so there'd be no need for a confidence interval. But we can expect natural variation to happen when different people are drawing blood pressure. Our last example. In a study of the length of time that students required to earn bachelor's degrees, 80 students are randomly selected, and they are found to have a mean of 4.8 years. And this is based upon data from the National Center of Education Statistics. Assuming that S is 2.2 years, construct a 95% confidence interval estimate of the population mean. Interpret this interval. B, does the resulting confidence interval contradict the fact that 39% of students earn their bachelor's degree within 4 years? Here's the Minitab printout. So A, we are 95% confident that the true population mean for getting a bachelor's degree is between 4.3 years and 5.3. Part B, no, the confidence interval is an estimate of the population mean, and it does not imply that 95% of the times are between the confidence interval limits. So when we interpret this, we are saying we are 95% confident that the true population mean, the average, is between 4.3 years and 5.3. Here's the readings and suggested problems. Thanks for watching.